a school, okay? So it's a fairly simplistic product. It takes the heat out of the condensing loop and puts it into the room, assuming it's a water to air heat pump. If it's a water to water heat pump, takes it out of the condensing unit or the loop, and then puts it into another source of water like radiant or hot water that serves fan coil units or hydronic unit heaters, that kind of stuff. In the cooling mode, it's very much in the reverse cycle, very much operates like your refrigerator. So it's going to take the cooling or the heat that's sitting in a room like the one we're in and dump it into the condensing loop. The loop will then, of course, warm up, and you'll have another device that will cool it down like a cooling tower. So in general, building loops are controlled anywhere from, say, 60 to 90 degrees, somewhere in that range. And there are many downtown buildings that have this, many schools, many houses that have it. So it's still not mainstream, and when I say that, really water source heat pumps are probably only about 2% of the market. So in the Seattle area, there may be a little bit more than 2%, but still out of all the systems out there, they're really only between 2 and 4%, somewhere in that range, so pretty low. So you got McDonald Miller just happens to specialize in them more than the rest of the fray. So that's how a water source heat pump works. Like I say, you guys are probably very familiar with those. As of late, they're being used in applications where you have chilled water flowing through your building. So we're seeing a lot more of that these days. So you'll have a chiller loop that's operating at, say, 42 to 48 degrees. Instead of putting in a fan coil unit, they'll put in a water source heat pump. Various reasons for that. That's more on the designer level, but you have seen it. Terry can witness it there for you. So Terry got to insulate 5 units in the field because they're operating off a chilled water loop. So he had to actually go insulate them so that they wouldn't sweat all over the place. So not a very fun thing to do in the field at all. We do that at AirTech company, and it's usually done at our shop. So we'll end up basically taking the whole unit apart and insulating it, but of course it's on our floor. It's a lot easier to do at that particular point.
And he's talking about insulating the units because the entering water temperature from that chiller loop is a certain temperature. So when it is below 60 degrees, as you would have in your boiler cooling tower, the unit needs to have some insulation to combat some of the condensation that would occur inside the unit. So that's why you're insulating it.
So if I'm traveling too fast, you guys let me know. So we've seen that lately, say in the last 5 years, and it seems to be getting more popular. They're putting them in on their chiller loops because their condenser loops are full. So they have a lot more capacity built into their chiller loops, so they're putting water source heat pumps on their chiller loops. It's also extremely efficient. So all of a sudden your EERs pop from, say, 15 to in excess of 30 and 40. So very efficient because you're using a lot colder water temperature to actually cool the server room or the IDF or the MDF room.
What about heat? Do you have a head pressure control on it?
No head pressure control because it has a TXB.
Still cold.
Yes, I have one in my house. So my loop temperature got down to about 28 degrees, and I don't have a head pressure control, just the TXB. So my first heat pump, it lasted 25 years. So I just put a new one in recently of the TE style. I've also seen the equipment, same style equipment you guys work on, operate at 17 degrees entering air temperature. So they will operate a long way down there in the heating mode. Cooling, that's a different story. But in the heating mode, they tend to be very forgiving machines, provided all the other parameters are within place. So that's as of late, that's what we've seen. Code issues, okay? So lately, say in the last 2014 and up, a lot of code issues have hit. So a lot of your sales crew are very familiar with those code issues. They rely on us to keep track of a lot of those code issues as well. You guys probably see a lot more junk on the machines now that you have to hook up: motorized water valves, certain balancing valves, certain types of balancing valves, depending on what the installation is. That just puts more pressure on you guys and us to know, okay, well, why do I have this on here? What's the point of this? And sometimes you don't have an answer. Just call us, and we can probably walk you through it fairly quickly on at least the whys. Why is it there? What is it being used for? What am I expected to see operationally from that heat pump based on this? And as long as you guys give us the parameters, we usually can, you know, it might take us 10 minutes, but it'll take us, we can usually get you the right answer and get you to the next, you know, get you to the promised land. So you can get the piece of equipment working correctly. So code issues are a big deal these days. Beyond the code issue, there are also 3 and 4 different styles of water to air heat pumps, okay, that are going in the downtown market. All you guys are also putting your hands on those things, and they're anywhere from the Climatemaster level to a TC unit all the way to a vertical stack heat pump. On the TC unit, those are used for a certain reason. You can get a TC unit with a PSC motor or an Ecm motor. Again, the Ecm motor, they're only going in there because they satisfy a certain EER and COP. Because they satisfy a certain EER and COP, boom, they're permittable. So when you get beyond that, you get to dual stage TY units, okay? The nice thing about those is they are the same dimensional cabinet-wise as a TC unit, but we're only using those, again, to satisfy a 2015 minimum energy code criteria. When you get beyond that, you get into the TS unit. Many of you guys have also seen those, and you're going, why in the heck am I putting this huge coffin up here? I don't have any room. I can only get 6 inches of blower access. A lot of those are going in, same reason, because there's no room downtown, but it has to go in, otherwise it's not permittable.
What do they do on a 2-stage hydronic heat pump? Is that a different compressor speed?
It's more of an unloader. So how an unloader works is it's like there's a valve inside the compressor that unloads and drops the performance of the heat pump. And in general, they also drop the airflow so that you maintain the same delta T that you would on high speed or low speed. So it's not a different speed, it's just an unloader.
Is that like a scroll, like a digital?
Yeah, it's a digital, it's not digital, it's a scroll, okay, with an unloader.
So does it go from a 0% work to 100?
No, it goes, it's approximately 100% operation or approximately 66. So it's part load. And it's basically a valve inside the compressor. If you and I were to cut a compressor apart, there would be like a bypass. So it's just called an unloader. You guys are probably familiar with those on larger pieces of equipment. So, so you got the TS, then you got the TS with ECM. So sometimes you can't satisfy it with the PSC, so you got to go to the ECM, which gains you another EER, and all of a sudden, boom, that satisfies a certain code. As of late, a lot of vertical stack heat pumps. You guys are going to start to see those. Some of you guys already do. So probably in the last couple of years, we've probably put in 2,500 of them.
Everybody know what a vertical stack heat pump is?
Yeah.
So a vertical stack heat pump is basically the shell of the heat pump will go in a closet in a room, and then all of the guts, which is called the chassis, includes the compressor, all the control system, and the heat exchangers, goes on a slide rail that can slide in and out of the frame of the heat pump. So when you're replacing it, you just slide out the guts and slide in a new one.
Not that easy.
It's not that easy. They're heavies. It's a little, yeah, so it does make replacing them easier down the line because you don't have to drop a unit and put it back in place. But you know, there is drawbacks to it too. It's a multi-step installation process, which can take a little bit longer the first time.
The ones probably 20 years ago, I know at least 4 of you in here have played with them, and they are not easy. You can imagine you're trying to replace a 20-year-old chassis, and everything architecturally is not lining up, everything control-wise is not lining up. Climatemaster was kind of the inventor of the vertical stack heat pump. So they probably have the best setup because they have a chassis converter. So it's a guess, okay, what you have in your installation on the new chassis. So a lot of you guys have probably been through that. We've lived through that as well. There have been changes, you know, no access ports, or the access ports are there except they're in the back, so you got to pull the chassis out to get to the access port. So there are certain things that say they did 20 years ago that they don't do today. So some of them I agree with, some of them I don't agree with. So the access ports, I do agree with that one. I know some of you won't like that, but that's based on what I see in the field. I kind of agree with that one.
What do you mean when you say the access port?
So if you look at a chassis, okay, which is about that high, let's say, and you're looking at the face of it, which is where the coil and the filter are. Down here is the controls, okay, right down in here. And in the back is your compressor, your water coil, your TXV, the rest of your componentry, and the access ports. 5 years ago, the access ports used to be right here. So you could gauge up, okay, close the return air door, and then watch what your machine's doing. You can't do that today. So.
Well, at least you're putting access ports on versus like Wayland.
Oh, they don't have access ports? I didn't know that.
We got about 6 of them sitting out back right now waiting to be repaired. I don't know that any of them came with access ports.
They didn't.
No.
Oh, that's something I did not know. That I don't agree with.
Yeah.
Yeah. So on ones, we actually have 2 full vertical stack heat pumps installed down at the shop. Okay. We also have a working water to air heat pump system. We have a ground loop at AirTech company, and so we're actually able to hook up to our condensing loop and run heat pumps. So if something is hitting us the wrong way, we're going, you know, I'm going to put that online. So we put it online in our little, you know, funky shop, and we're able to actually run the thing and see what's going on. We had to do that for 2 vertical stack heat pumps to test noise levels.
You want to do that with a couple of Waylands?
You know what? I'm sure we could figure out a way to pull the chassis out and throw those in, but you can also do it with a hose.
That's what we've been doing.
Yeah, so you can do it with a hose, but it's a pain in the ass. So and then you got to run power over there, so it's not easy. So.
That's why Seth's shop is a mess.
Well, yeah, and plus it's very time consuming. So you try and, we normally try and talk the buildings into putting a test stand in. So most of them do. Most of them put a test stand in. The ones that don't, they're sorry they didn't. But they really need a test stand, which is nothing more than putting in 2 cabinets with the valving, with the power there, and then you're all set up to go. So.
Again, this is for a vertical stack test.
Yes,
That's it.
specifically, the vertical stack thing is not gonna hit mainstream in Seattle probably for 10 years where the replacements start. But when the replacements do start, I mean, you guys are, McDonnell Miller is slated to probably go in there and replace the lion's share. You guys are in the downtown arena. You operate in the downtown arena more than anyone else. So, so you gotta be set up for it, you gotta be ready. But it's gonna come, and it's gonna be a lot of them. So, vertical stack heat pumps tend to last not as long as a water to air heat pump, because they're more going in condos and apartments. And so more condos and apartments, instead of fix, they say, take it out, put a new one in. Especially because it doesn't take very long to put a chassis in, assuming the chassis is accurate to what the cabinet is. So we have generally changed out a chassis one to the next. We can probably do it and get it running within 30 minutes. So it happens very fast, very quick. So, not the old 816s. Those aren't as quick. Yeah. So that's the general gist on water to air heat pumps, how they run, where they came from. That's the history of them. As far as Climatemaster goes, so I thought we'd kind of jump into, before we go into some of the components and parts and startups and stuff. I'm assuming everyone knows what a water to air heat pump is and how it works. Excellent. Okay, perfect. So before we move to those, does anyone have any questions?
I ask a question, and this is not technical, it's more economic. If you're sort of budgeting, what do you think the life of one of these is? 10 years, 20 years, or just depends?
It depends on maintenance a lot of the time, but I would say we're seeing, because we handle a lot of the parts, we're seeing equipment replaced in year 43. Okay, we're also seeing equipment replaced in year 11.
Okay.
It depends on the scenario.
Okay.
But I would say in general, if you're trying to look at a number, I would say anywhere from 20 to 24 years.
Okay.
Somewhere in that range.
Perfect, yeah.
Yeah, so a long time.
Yeah.
You know, they're indoors. So they're not outdoors, so they're gonna outlast, a gas pack or something like that.
Got it. Perfect, thank you.
Okay, startup, because the three of us do a lot of startups, there's certain tools and stuff that we walk up to the job with. In general, I'm walking up. Again, I'm not a refrigeration technician, so I'm not carrying my gauges with me. So how do I find out and answer though? I'm usually on startup, I'm taking my fluke meter, my amp probe, which is, I just use that just strictly as amps. My temperature thermistor, okay, on that I'm gonna use it with, I'm gonna have a clamp to measure water and refrigeration temperatures, and I wanna get air temperatures. So, once with these, and then bolts, okay? I wanna make sure I got the right voltage going where it should be from a control standpoint or a line voltage standpoint. Usually with that, we can get you to 90% of where the issue might lie. 90%. Once we know all the data, we can start figuring out where to look if there's an issue pretty quickly with that type of information. So on a water to air heat pump, generally the GPM for it to operate efficiently is anywhere from 2.5 to 3 GPM per ton. And that's in some of my notes that I have for you guys. 2.5 to 3 GPM per ton. And that's gonna give you, in the cooling mode, 10 to 12 degree water temperature difference. And in the heating mode, anywhere from 5 to 7 degree water temperature difference. So 2.5 to 3 GPM, it's been the same for 40 years. So on the air side, we're looking for anywhere from say 18 to 25 degrees on the cooling side. And on the heating side, we're generally looking for 25 to 32 degrees on the heating side, somewhere in that range. Sometimes it gets hotter. Okay, that leads us also in a direction. So If it's too warm, 40 degrees, okay, we probably have an airflow problem someplace. We gotta find it. Could be internal. I found one this morning. So, in the cooling mode, if it's running at 30 degree delta T, or 30 degree discharge air temperature, same thing. I got an airflow issue. There's something going on. I'm about ready to freeze the coil. So, on the water side, again, fairly self-explanatory. If I got too high of a delta, I got low water flow. I gotta find out why. So there's lots of different reasons why that's gonna crop up. Underperforming pump, you got a blocked line, you got a blocked coil, or it's low delta. Could be low on charge.
Or fan running backward
Or fan running backwards, or compressor running
on
backwards.
single stage. It's running backward on single stage. On
Single phase?
phase,
Single phase?
yeah.
Yeah, first step would be, switch the leads to the capacitor. That would be step one.
Yeah.
Who showed you that secret?
What secret? It's not a secret, everyone knows it, everyone here. You sent an email out to tell everyone, didn't you? So, again, we're just trying to run through the, the things the scenarios that come up with us all the time. So, but anyway, that's the tools that's gonna be in my tool bag, besides all this stuff over here, which is basically wire cutters, snips. I'm not a Makita guy, so I always bring my nut drivers. My guys always give me a bunch of shit about that, but, and then my control screwdrivers. That's about it, and a light. And that's what I use, so, to start up a heat pump. So these guys have something similar. They use Makitas. You guys probably all use Makitas too, so I'm more old school. So.
One tool that he doesn't show you here is, and didn't point out really, is that there's
Oh,
a
yeah.
jumper. This is just used to simulate the controls when he's diagnosing it. He can plug it in right to where the controls goes, and then take off leads as he needs to simulate a call for cooling or heating or fan only. It's a must-have if you're actually gonna work on the unit.
Just flip switch number 4 and that's it.
Otherwise, you just use really small paper clips.
Yeah, those will work too. We just find that the jumper wires work fast and quick, and I'm sure most of you guys have.
And if you don't have them, next time you come to AirTech, we have buckets of them. We can use them.
So, yeah, we use those all the time. We also use those, okay? Some of you guys have seen the ECM setups where you have to actually jump out, and I didn't bring one, but,
ECM.
yeah, do you have the ECM? Oh, here it is right here.
Oh, I see what you're saying. Yeah.
Okay, so here's what's on the ECM board, okay? A little bit different than that, okay? A little bit, however, the pin connection is the same. So you can use this for this. You don't have to actually yank that off and then put jumper wires in. You can just use this. So you take this off your belt, plug it right into the ECM board. You're off and running. Just verify connections, they're all right. But that's generally how we do it. We'll use the exact same one. And we start. And so I'll usually start in heating. A lot of the times, if it's cold, I'll start in heating. If it's warm, I'll start in cooling. And off I go. If I get a good delta on the water side, I know I'm gonna get that same result basically in heating or cooling. I always like to pay close attention on the air side on both heating and cooling, because I'm gonna let it go for a good, on R410A, I'm probably gonna let it go for probably anywhere from 10 to 20 minutes in each mode. So I know that the refrigeration will settle out. R22s are faster. They're gonna give you the performance that you want much quicker. R410, not so. Takes longer. So, and you can also at that same time then see, after 20 minutes, you're gonna be able to see if you don't hook up gauges, you're gonna be able to see whether you're overcharged or not. So, and that'll happen fairly quick. And all of a sudden, if you hear your compressor winding out, it's probably time to put gauges on it. So, at that particular time. First thing we check for is compressor rotation. I would say 50-50, it's wrong. So, it's, we get very irritated with people, plumbers, okay? They go in and actually will throw a disconnect and start a piece of equipment up, and they have no idea what they're doing. Or a control contractor. You would think a control contractor knows what they're doing, they don't, in general. So they'll go in, turn the unit on, and then start controlling it from a remote source. And all of a sudden, they can't get it working, so they leave it on and walk away. And all of a sudden, come back in a week, or say Mac Miller comes back in a week, or someone calls and say, hey, I got a dead compressor on a scroll, and well, probably because the rotation was bad to begin with. So that's something we get fairly irritated with people about. Now, the good thing is, all the techs pretty much know that, all the good techs know that you have to check rotation on scrolls, and you have a very low incidence on bad compressors out of the box or out of the piece of equipment, say, than you used to have on recips. Recips, per 30 units, we would see probably 3 recips bad. That's a pretty high percentage, you know, that's a high percentage. And that was fairly accurate. That's from us doing school jobs. We knew how many compressors we would have to replace. Scrolls, it's so non-existent that I can't even tell you. I would say maybe 1 every 500 compressors. Pretty low. Pretty low. Other components, okay, we're not so. But as far as the compressor goes, pretty low. So, so that's the things that I'm going to look for startup when I get going. And generally, most startups, they go fairly simplistic, unless you get into oddballs. Okay, you get into oddball things, which involve some of these pieces of equipment that we're sitting here looking at. So I thought maybe this is probably a good time before we get into some of this stuff to run through the boards. And it might be easier to, Kenny's gonna roll it up here, and some of you guys can get around. We're gonna first start up a DXM board. This is our test stand that we utilize at the office all the time, because if you guys call in and have a question and we can't answer it, we're gonna fire one up and we're gonna run through it. What we've noticed in the last, say, 2 to 3 years, dip switches. There's a lot of different uses. Climatemaster's control board, okay, is extremely functional. So you can do a lot of different things, boilerless control, different delays and boards. It has accessory relays. A lot more people are using that kind of stuff. So one of the things that we've tried to, put into our scheme of things is right away, what are the dip switches set at? So we didn't used to do that at all. So, Kenny. Some of you guys are gonna have to file up to see all this, so.
So we just have basically relays set up so we can test different functions of the board. So we have one for the fan, reversing valve compressor. And so this is basically like when someone calls and has an issue, we can come over here and start running through different scenarios. Some of these aren't functional right now, but we have switches for all the different safeties so we can simulate different faults. And so I would say, probably want to come up here, like make kind of a line. Unless you guys can see. The DXM is pretty simple. Also with warranty issues, when someone brings a board back, we'll throw it on here to kind of double check their troubleshooting. So this is the jumper we use. And obviously we have Y1, Y2, from overcooling, D-fan, R, 24 volts. So right now we're in heating. So, like when I'm running this stuff up, I'm running heating. short pin.
Like this.
Well, I do that too, but you know. I don't wanna, create bad habits.
You just stick your finger in one place.
And that one click, that tells you that it's in test mode.
Yeah, so when you're in test mode, it's gonna click whatever the last fault was. You guys are probably seeing that. Right now, since there wasn't the last fault, it's just gonna do that one click every 10 seconds, which is just. Alright, so now we got compressor. No, I don't. Does that. And then so obviously when we wanna go in cooling, it's always better to cycle power, take the call. And then like I said, some of these are functional, the switches are old, but like, I know this one works. You know,
Make fun of shit like it comes out.
it's mediocre, and it'll give us the code. Code 2, which is high pressure. So, this is pretty simple. The one that you guys will wanna see is the ASM2.
So the bad part about the DXM and the DXM2 is that you won't really know which one is which. They look almost exactly the same. So
as far as the boards.
yeah, so they.
The one difference you'll see is this test button.
And the connection, right?
Right,
Yeah, I mean-
that is really the only thing that's gonna tell you what it was unless you know what the part numbers are, which you're not.
Test button doesn't work.
Um,
Oh, really? Yeah, if you try to test it out like you did up there, it's good to just.
No, it will work. It's just you won't.
It won't. It won't work.
Didn't work on the one you were on?
It will work, but it won't, you can't do you can't like test out the whole system. It will fall if you just hit the test button. On every one of that I've tried, it's faulted. Cause like if you hit the test button here, to make it come on, if you try to hit the test button here without the module, it won't work. If you're just calling it, if you just have and you just hit that, you have to wait the 5 minutes and let it.
Oh, I got you. I've never tested it, I guess, like
With
that.
the, yeah, because you have if you don't have that module, you can still start the unit.
Right.
But
Okay.
if you have the module, then that test works. You just hit the test. But if you don't
I
have
got
that,
you. I guess I never tried it.
Can you give them the finger routine on the test?
I already got one of those.
yeah, this.
Offie already mentioned it.
Okay.
Anything above 16 seer, it's like the 22 seers and the 30 seers are those ones.
That's the DXM2.
Yeah.
So this one is 16 and below, sir?
Yeah, 16 and below.
Yeah.
So it's basically a glorified stat. You can run the machine, assuming it's been set up properly, which you can without this. But what you need this for primarily is for balancing, because you have to set it's the only way you can set your air CFM values. You know, the old Ecm boards, I don't know if you guys are familiar with them, but they had a DXM and a separate Ecm board, and you set your CFMs with those dip switches. So on this one, it's also, that's another thing is when you're replacing one of these, you have to have this because you have to reconfigure the board. So you have to go into system config and actually put in the series and ton. So I'm using the TE. You have to have a fan.
No, Kevin's right now, but. I don't know, somebody told me.
And so this is what everything you can do. Now, a lot of the time you're not going to see.
The problem is, you gotta make sure you get
So a lot of times you just do it eating one, borrow them to use it.
Most of the
That's what we. CFM
Well, no, we just want to. Instead of changing the whole coil,
And so another cool feature of this is manual operation, is you have all the Y1, Y2, O.
Right.
So you just go in there and heat up and all that water. We're gonna go stage 1 and 2 on, cooling.
Luckily, our Fitter Brothers put in a low drain, so should be able to get the bulk of the coil.
Then we'll start.
A little nitrogen behind it, going out.
Patch this too, and then from here you can also adjust it. You can either push it here or you can do it right here.
Well, for us,
Oh, okay.
we have to
You have to document.
yeah, we have to document pressure.
But that will tell you
It'll tell your pressure discharge.
One of these
it'll tell you, but to get like super heat pump, you gotta.
You didn't trip on my head?
No, dude. No, well, actually left the floors vacant, so it was off when I was doing my maintenance.
That's safe.
they're coming out with on there.
They're either so sensitive.
Well, it's capacitor, it has extra capacitance, that's what you want.
That's a good example for showing how
Half
you
the time.
pull it against a flat surface, so you can see the voltage. Because to the untrained eye, that might look okay.
Yeah, we started selling these.
Goal spotted right off the bat.
Yeah.
That's what we read about.
Actually, those valves
Put
actually
in
work
one,
pretty
it
good.
was a one-off, like the whole floor, they put in all of like 16 of these ones, and they had one unit that was this. And we thought it was like a mistake, we were like, they must have just accidentally sent this.
But they're easy to wire.
But then we
You
have to go
the,
get those because.
you actually have, one thing you have to remember with these valves is they charge. But that light will blink.
But these are only on TY and TE and TE.
So it can close when it loses power?
No, it's just the starting port to open up. Yeah, and then it just,
The black and gray.
then it will spring it open.
Okay, so now we're running cooling.
So do you run into problems with those opening too slow and it's trickling on high head before it opens, or is
No,
there
you
a delay?
make sure you wire in the
And
in
so
switch.
you got your,
Okay, oh, there is an in switch, okay,
Yeah,
cool.
so
So
24 volts and in switch, and you can bring a 24 volt
and you're
in,
entering
put
heating
jumpers
water,
over
leaving
here,
air.
and run out to your compressor.
And so this is made startup.
And then they have a little override.
And what I also like about it is I can
Push
troubleshoot
down on this.
the refrigeration side without having
Open
gauges.
and close it.
Just based on what the preset
And easy to change out.
like if they're
I
diving.
watched them where they don't have an in switch, and all the time you'll see them where they,
Then I got an idea.
the compressor's just, the amps are just going up and up and up and up and up, and tripping, and it's like, the valve will just open, and put in a bunch of like delay on make time.
So,
You have to do an in switch. That's what
in
they have.
Climatemaster, I know this is like circle.
Yeah, that's good.
And so with this.
I don't like the, I mean, delay on makes are nice, but then like trying to get them to mount inside those things, having a screw long enough, it's like, fucking underneath in your van.
That NTC is fine.
Oh,
Not anymore.
Bet this guy could in 4 or 5 minutes.
On my, laying on my bed eating a Twinkie. You flick that NTC.
I imagine my bed just flicking that thing.
so any questions about these?
Yes, I know why they call me that, and everyone's like, no, I have no idea.
You look like Violet on Charlie and the Chocolate Factory.
Yeah, so like for instance here,
Because we need that.
He was an asshole.
Right, so-
He was super rude. Like,
right, so if I tool diagnostics for all my temperatures work.
That
And I go to the
NTC.
right, it shows you.
So
I know what's wrong with it. I think that's what he's doing.
Just create a problem. Hey, if something's broke, you gotta replace the motor, that frame, break something, now you gotta replace everything.
So that's what the first screen is.
I'll spend 2 hours diagnosing why it failed. Then I put the new motor in. Why do I need to do it? That was so funny. I was getting flustered by that.
That's where you can say, okay, I gotta call this.
You can feel that solder.
Yeah.
You can also go in here and
A little bit of this.
look at all your gas switches. You could also clear your history. You have to do that in the test mode. I don't know. That's one thing. Time and sequence. And you said.
No, we don't.
then one thing, like, when you are playing with these on a unit, what Kenny and I always do is we always unplug the customer controls or the building controls from the board. You'll backfeed into this and it'll try and run it.
Those get great next to
over.
Oh, yeah. You run a little bit of water through that thing
Or when you're
too?
diagnosing.
Mostly lube.
No, I wouldn't,
Well, I do.
you can leave the good one on diagnosing, because you may wanna see what it really.
Sorry, yeah, if you're trying to run it from this, you run it off like this.
Low water.
Yes.
Can you control that input?
Excuse me, so make sure you cover when you're starting it up on that, and it has an internal motorized.
Yeah, it is.
water
It's not,
Oh,
it's a high split, it's not because.
Can you,
You talking about the mod valve?
mod valve or two-way
On
valve?
the
No, we were
west.
talking
Remember, it
about-
won't, because that won't open the mod
Yeah,
valve.
but you're slowing the water.
We're
down.
talking about.
Remember, you gotta manually open the motorized
It's just-
valve
It's just insulated.
when you're starting it up.
It's a low split.
I didn't know that.
Yeah. Yeah.
Even a little takeoff?
Yeah, the water
Yeah.
slows
It
down.
won't open?
No, it won't.
Oh, that's right. Okay, no, you're right.
Yeah,
you're right.
yeah,
That
so
makes sense.
explain that to them.
Yeah.
Right,
but
it's the
that's-
way
Are
the
you talking
wiring,
about if it's scaled up?
the
Yeah, if it's
internal
scaled
valve
up,
is wired.
We've seen
Yeah.
scale,
See?
we've seen slime.
Okay.
Oh, yeah.
The wire.
You get your finger in, it's so
Is there
slimy.
a line that comes off
The
here?
open loops
Yeah,
can see.
Wired with the.
You normally see a high split
Control
because it can't move in the
wiring
water.
from the stat
If it's really.
and one
Yeah.
side of the end switch.
But even the brave valves, right?
We have shits where they don't have a,
I don't know.
Low
I've
screen.
never seen
Yeah.
one that has low split, but you have a high.
That's
head.
what I was saying.
Anytime there's a motorized water valve in your
trying to tell you back then.
That's like that causes you a lot of headaches. You're like,
But I
why-
tell you,
why am I tripping out?
one time I was
Seth, don't do that. Don't inflate his inflated big ass head.
No, no, let me tell you, because 99% of the time, Roger will be right, and I'll be wrong. This will be like the one exception. Actually, one of the first times ever.
Well, he's not wrong either.
To our area.
He's not wrong either.
And the options.
In this area.
Option selection.
That's what we get, bro.
Hard water over there.
Then go drink Yakra water. It's supposed to keep the cop, that crop screen. The cop screen. Yeah.
Internal modulating valve. I spent 2 months going back and forth hard review on a unit. I replaced boards, MPC controllers, beating my head on the wall. And it was because
I could fix
the
it.
guy didn't put up, saw a valve on the outside, he put it on.
that was.
That's all it was. That's just that I look for, if it's not running, it's freaking out, that's every person.
No.
Because we've only sold like maybe one modulating valve, maybe one or two.
Yeah. So where's the modulating valve? It's
It's actually internal. It's on, yeah.
It's where this valve is, and you've seen that.
Yes.
That's where that valve is.
So on the TV units, you don't get this valve.
It doesn't look like that?
It's different.
Oh, yeah.
Modulating valve will act like your person.
And so you run that other valve, you need to turn that on.
I'm just telling you that you're gonna see that.
That's different. That is a no,
You're gonna see
not on the
no,
modulator.
Don't ever turn that on.
No, because it's wired into the
Yeah.
board itself.
It's like $700.
So do you have to flip that to a
This
different
way,
frame
It
still?
looks about the same frame as shaft.
I don't know, because we sell so few, it's right after the.
Maybe it's
Horsepower. Right. Doesn't even say.
It won't be norm in
Maybe I'm
the
wrong.
commercial.
Okay.
I got 2 points where I was just like, I don't know what's trying.
They are cool. They are cool when you work.
Hey, use comes in handy, dude.
You have a lot of practice.
And
Well, this is a cat.
Like $300. We have a.
Mike's gonna give him.
No, I think
Everybody's walking out with one leg.
Because got a call from
You guys are only
Thermostat,
talking about
measures Y and R.
Yeah.
Compressor's not
We
coming on.
want
Yeah,
that.
domestic,
First thing you're
domestic
gonna
top
do
cost
is
research.
check all of the
Even if it's not,
I know that it is that for, and I'll show you.
generally, the general rule is if it's from the main system to a valve, and it's from the valve to the equipment.
Just
you can work on
because
it.
you're
If it's that valve.
but you think you're 24
let
volts,
that
for
be
a
a
call
fair-
for the compressor on the
Or
power,
the
that
bigger-
doesn't mean
that
that's
general
actually.
It is that.
If you can't valve that off and work on it, well, I know, even if it's out in the system.
So, and that's another thing.
Happens all the time.
Another thing.
Don't press the board.
Speaking of the CCG, so out of Both boards are very similar, they both have these two wires. And those,
Cause I honestly, I
that's
know
where your
myself.
24 volt
You'll probably have
contacts
this experience sometimes with
That's what
building.
And so
I tried not to.
one of the most common reasons the boards fail
Yeah, I know,
is
that's what I was looking
either.
at.
Before I open or cut it, I usually.
And I filled that out.
And so
One
I'm
is
supposed
filtered,
to
and one is filtered.
uh,
Hey, how can I?
And I noticed that
Outside air, so it
Yeah.
plugs up into it. I
At
think
the
one
end
time
of
I
it,
remember putting that
you
in.
had 20. Right.
2-inch.
Or maybe it's the opposite.
I do see John big time,
Contact
inches
schedule.
all around.
That can be
From
right.
2 inches and stuff.
I shut the
So I always tell people, when
For that exact-
that is something you
Cut it out.
troubleshoot,
Because they were
you
just
check
like-
here with the
I remember
wires on and also check at the back.
I had to do this, I had to do this.
Plastic
Because
sometimes.
sometimes the
You know,
connection.
put the water.
Right, or the contact, and it was just a
We had a breakfast meeting.
Right,
next
right,
morning.
right.
I was driving back from 13 Coils.
and that's something I saw twice already. None of us do. I always go through any of the wires.
Roger's,
Plus you also.
in a good way. Don't freaking, hey, what
did
was
that
the,
by
what was the
touching it
discharge
on
to
how-
your unit?
First thing you always wanna do when you turn on the unit, check for
Who checks that?
rotation. Plumber comes
Kenny's
out.
got a really good way to check that instantly.
Then just
He'll flip it on
I
before you
would never
can
handle-
control.
I would never handle
He
voltage.
takes his pen.
I don't know why I put that. I just listened to
Yeah,
it.
and most,
I said
you're only gonna be doing it on three-phase, so you don't see the three-phase contact, they have the button in the middle.
Yeah, little baby
I
steps,
just
dude.
take my pen, compress it,
Johnson,
Yeah,
boy.
I can push it down.
And right away you'll hear whether the compressor is
Showing up.
exactly.
You can tell who
That's the very
together,
first thing.
so.
We'll always.
Who used to work together?
Is it spinning the right way? Okay, good. Now we can do
Please.
the rest.
It's the sleep.
You messed the thing.
You fucking. Nobody else. Well, maybe all.
That cover 'em?
Nobody else.
Yeah, unless anybody has any more questions, some of these guys go over those.
You guys got any questions on this DXM board?
Okay, so
Probably do, but.
So they're hooked up to the,
Down here.
down here, and you're the chamber, you still gotta put the.
You got it figured out?
You getting there? Getting there.
Figure I just keep coming to stuff gets.
DXM is great for all.
So we don't have that chamber. Start the unit.
Access. I know there's some. Motorized water valves and all that kind of stuff. Motorless controls, it's got lots of.
No.
I'll tell you what, I'll tell you guys why.
I'm certain we didn't know.
It's like their model.
It literally took like 4 hours. It won't. We were trying to figure out like. We went and tested it out.
Oh, they took
And there was a problem.
I'm not gonna go. We want to give it to us. They're not there. This is so, this is a lot of.
I do a lot of,
Start fixing was something that.
Okay.
Moving along.
and it's all right.
No.
I don't know, there's a lot of like, I can't like from the back.
Okay, so just to kind of keep going, so you guys heard a lot about the boards, DXM, DXM2, okay? A lot of you guys had great questions, which was, you know, like, hey, I want one of those tools. Hey, give me one of those tools, okay? We have quite a few tools at the office. It makes no sense to carry one around in your van because there is 10% or less units that have a DXM2 right now. Very, very few. We stock probably only anywhere from 5 to 10 machines that actually have a DXM2 because that's all that we need to satisfy the code. So DXM2 also comes with several different things, which you probably saw on Kenny's. It comes with a entering water temperature sensor, a leaving water temperature sensor, a leaving air temperature sensor, a condenser water, not condenser, but compressor discharge temperature sensor. It has a couple other sensors. It allows you to see the LT1 and LT2, which we haven't been able to do in the past. All of that stuff costs money.
So that's
So-
an upgrade from the.
That's the upgrade from the DXM. We would like to see it go that way. That's kind of where
That
air,
lets you use this tool.
yeah. And we're pretty much seeing that this is gonna be the future.
Does McDonald Miller own
No, and
one or
like I
more
said,
of
yeah,
those tools?
we just don't.
You guys don't have them in your possession yet, but yes, you do own some.
We own one. Well, I have one in my possession.
Yeah, we've given them out to some of the guys. So
But
some,
what's it take to get one?
you already have some. They're just sitting at my desk.
Because like, I know like the Portland guys, like I don't know if they have one.
Yeah, so therefore, like Brock Lee, one of your guys' sales guys, is doing some jobs that specifically have quite a few of them. I bought them some.
Okay.
So, but they're not to the startup yet on that job,
Is it Met Park?
Met Park.
We are,
So,
we are starting.
okay, then you need the tools, and I got you some. So whoever is in charge of startup, and I sent Brock probably maybe 2-3 weeks ago an email saying, hey, I got some stuff here, you need to have them. And you wanna come in, who's ever doing the startup on that job, and we will run you through it again, and we'll show you how we were.
We have one, because we had the one-off unit at Dexter, and you guys gave us one. And
Okay,
so-
yeah, I mean, we have extras, and so
We're
we've
using
given
it.
some to you guys. Some of you guys have come in and borrowed them, but it just doesn't make sense to have 50 guys have them when there's so few. So, but yeah, we already have some for you guys.
Just so
So-
you know, on the tool, there's a cord and it tells you on each end which side plugs into the board and which side plugs into the tool. Not sure if it makes a difference, but we just follow it. Also on the tool, these do occasionally burn out. One thing I've seen is if I'm not plugged in correctly on the board, let's say I'm off by one prong and I only have it in 3 out of the 4, this will start to smoke immediately.
That's good to know.
Smokage, yeah.
Do you guys sell that smoke injector kit to get the smoke back in?
Yeah, that's called the magic soccer juice.
Also, if you're looking at this and it looks like it tells you that some of the data is incomplete or everything starts coming up NA, it's bad immediately.
Well, before you call it bad, I would cycle power, because I have seen it say NA.
And
I
mine's
cycle
come back,
power and it comes
yes,
out.
yes, I've had
But,
that happen too.
they do fail. They say in the manual, do not plug it in while the unit's on, and do not unplug it while the unit's on.
Go ahead and give them our personal
I
opinion on
think-
that, yeah.
That's bullshit.
I think it's bullshit, because how are you supposed to walk into a unit that is in fault or having issues and troubleshoot it? So I just plug it right in when it's on. And it
So do we,
doesn't kill
all
it.
of us do. So
It may have killed one, I don't know, but not right away.
each one of the tools comes with this handy little fancy case, okay? So there is protection at least, so it's not like you're just, here's your tool, okay? Because that goes into a van and within a year it's gone, okay? So at least you'll get a case with them, and like I say, I got you guys at least 2 for Met Park, because you have to have them to do the startup.
Yeah,
So.
I had to pick it up from the other guy today.
Okay, good. I have, like I say, I got 2 at the office. So, we all have them. The reason we have so many of them right now is because we are doing a ton of vertical stack jobs. All of them have the DXM2, all of them. So, and we don't see them going mainstream for within the next, say, 3 years or so. We're pushing for it. We want it done. It's the East Coast, they don't want it, because they don't want the money. So, we feel it'll save, it'll take you guys in the field, if the unit has a DXM2, we figure it'll take you guys in the field, you at least an hour savings per service call if it's a DXM2. At least an hour savings in the field, and that's a big deal. That's a lot of money. That's, ballpark $150 right there, savings. So multiply that by the amount of units. It doesn't give you refrigeration information, but it kind of does. It gives you LT1 temperature, LT2. We're able to diagnose low charge or bad TXV utilizing that tool. And we're usually right 99% of the time. So
99.
longer like what you saw, the weird shit like the plug.
Oh,
Yeah, so.
Stuff like that. we can-
When it goes beyond that or something weird, okay, you're still back into your traditional, okay, I gotta gauge up. So, but in general, it is, we're seeing it as a pretty big benefit time saver wise. So, okay, so that's the tool. We're gonna run through a few other things that we've seen over the years. A couple of you guys were looking at the tube-in-tube water coil, okay? This is pretty much the same water coil that Climatemaster has used. It's a coax water coil. It's been used for 40 years. We still utilize it today, okay? It's, for the most part, it's, it's very bulletproof. It lasts a long time. You see this green stuff in here. This unit came off a ground loop, okay? And they had water quality issues, okay? One of the main water quality issues they had with this particular heat pump is someone put a coil, or excuse me, a marble inside, got stuck in here. So that's the reason it killed the machine. We end up with a water coil. We cut this particular portion out because we thought it was cool. So, but that's what they look like on the interior side. Water on the inside, refrigerant on the outside, between the jacket and the copper. So these coils come in Cooper nickel or copper, 99.9% of them copper. Cooper nickel is going to be for a different application. Another thing that we thought was cool, we had a residential contractor, okay, saying that they had replaced 3 reversing valves and saying that they for sure changed the filter dryer every single time. I felt they were lying. I went up and we did it ourselves. Changed the reversing valve, changed the TXV, changed the filter dryer. This was the filter dryer that he said he changed 3 times. He obviously never changed it. So that's what they look like. That's the purpose of them. This is obviously a dirty, bad one. So I know there's a lot of, everyone always says, well, why? What does it do? Okay, well, it filters. That's what it does. This is how it works. This is a very dirty one. They got little screens in there. So that catches obviously the large debris. They go here. They have one on the other side. We also thought this was kind of cool, so we cut it apart and wanted to see what the hell it looked like.
Can you pass it around?
Yeah. So here you go.
On that heat exchanger, do you have any tips for back flushing or
Yes.
signs that it needs it?
Okay. So back flushing of a water coil. Pretty much it's an old school technique, okay, because that's all there is. There's not a lot of literature out there on how to do it. But step 1 is you back flush through the discharge water line out the supply, okay? You hope, okay, that works, because the next way to go about it is not so fun, okay? You hope that gets it done. It happens on, I would say, on every single project. I would say I see 1 or 2 coils that are plugged, and it's usually from very light debris that's in the condenser loop, and they just get crap in there, you know, bottom of the loop or what have you. So it usually gets solved by just a single back flush. You can do that there, but you got to have a 5-gallon bucket, okay? You already have water there, but you got to hold the 5-gallon bucket on the water inlet side and go out the return down into the bucket. And if you're going to get anything through it, you're going to get it through pretty quickly, and it'll be black and gunky. You guys have seen it before, okay? It's pretty shitty. If that does not work, okay, the next option is open your water valves, put everything back together again, open your water valves, and let it cycle on high pressure, okay? So you got to let it cycle on high pressure and try and break it up. So Once it's cycled a couple times, just twice, okay, on high pressure, then, and the easiest way to do that is you do it in cooling mode, okay? And, because you don't want to freeze the coil, because that's not going to help you. And you just kind of really crank down your water to like nothing practically. But just let it cycle. Since there's no water flowing over, it's not really going to matter. But once you start cycling, hopefully within 2, that breaks it up, okay? Then you can do the back flush thing again and send it out. That's the hope. Third, place the coil. So, or, you know, shove a hanger up there, you know, you get into the old school stuff then. So, but
You ever use a pump and chemicals, kind of like?
you can do the pump and chemical routine, but it's still gotta go through just like Drano does.
Right.
So
So if you have any flow at all, maybe it'll open it up.
maybe if you've got some flow, then you might have shot at that. So we have pretty high pressure, we also do geothermal. So on our contracting side for geothermal, we have some pretty high pressure pumps. And that'll get you a little bit more pressure, say, than just your standard condenser loop pump on a building. Most people don't have that stuff. Maybe Mac Miller has some of that stuff, but you can go in and you can have a pump that's capable of, say, 300 PSI, and you could try that. I haven't had to do it that way. I've usually done the high pressure trick. That's worked. High pressure trick. So.
Yeah, we have some boiler, like hydrostatic pumps.
Yeah, that's what we have, the hydrostatic pump.
Yeah, do something like that, or there's that multi-stack, plate to frame heat exchanger, or braze plate heat exchanger cleaner, if you ever use that, takes the chemical out. I talked to a coil manufacturer once that told me, if you can't, like back flushing doesn't work, take your hoses off, let the water drain out. Use a vacuum if you need, but get all the water out. Put the unit into heating, so and basically freeze the coil. Run it until you get that water coil frozen. But you can't have water in there, obviously, because it'll expand and pop the coil. But get all the water out, let it run until it freezes, and then put water back to it. And hopefully you'll freeze that debris, and then it'll break loose.
Yeah, same principle.
But I've never seen anybody do it. It sounds like it makes sense, but
What could possibly go wrong?
has anybody ever tried that?
Well, I've tried it, but not in heating. I tried it in cooling. So, because I didn't want to freeze the water coil.
Yeah, well, if you got the water out, you'd be basically freezing.
Probably be okay, but all I saw was danger, Will Robinson.
I mean, if you're gonna replace the coil anyways.
Yeah. So, no, I mean, you're right, but I just ran it in. I just wanted it to trip on high pressure a couple times, and that seemed to, for some reason, it broke it apart.
Yeah.
I've only done it one time though.
Yeah.
It doesn't happen very often.
Yeah.
So it's very infrequent. So obviously, condenser loops that are dirty, which you guys I'm sure see a lot of them. It's hard to save an end user from themselves sometimes, but we can try. Okay, but it's hard to do. Usually, if you look through a service technician's notes for years, which I have done, okay, because I've been asked to do, it's amazing how many times a service tech will write at the end of their notes, extremely dirty loop, notified the end user. And the end user promptly looks at that and says, oh, he doesn't know what he's talking about. And you know what? Sorry, most of the time, yes, they do. Yeah, so end users need to pay attention to what the service technician says. That's the reason they called in the service technician. So that's the only time I've had to do it as far as free up a coil is high pressure. So, but you're in a dangerous spot. But you're right, if you got to replace the coil anyway, oh well. So you can try that stuff. But most of the time, water is work. That's just a backflush of water. That's on the coil. Okay. Okay, here's another good one. You guys I'm sure you guys have seen this. This is a capacitor.
This is for a 5-ton compressor, scroll, and this is caused by low voltage. So this is normally caused by low voltage to the compressor. You guys may not run across this very much. This is a huge deal in the residential market. You can see how it's bulging. Okay, this is bulging. Eventually, okay, it causes the compressor so it won't get its power, and boom, it can't start. That's something I've probably seen, where, 5-10 times? We've had to replace compressor. The first thing they do is order a compressor, and we're like, well, wait a sec, have you replaced the capacitor yet? Okay. Well, no, why would I do that? The compressor won't run. Yeah, but you can't get voltage to it. Place the capacitor, boom, off she goes. That's usually caused by a low voltage scenario on a residential application, of which there are more and more residential applications in downtown Seattle. So watch for that kind of stuff on 208, 230, single phase. So all Climatemaster heat pumps that usually go out the door, so when I say out the door at AirTech company, 99% of them, okay, they have a fused transformer. Fused transformer. We had one customer that insisted on 50 VA non-fused transformer. On startup, we fried at least five transformers. So where normally we would fry 0 per 10 jobs. So, but all in general, they go out the door with us. Fused 75 VA, because we like that to be able to power all external controls that are connected to the heat pump, which include the damper motors, the motorized water valves, the external controllers by ATS, Johnson, you know, all the different control contractors. So we like it so that we would power them rather than them supply an external transformer. So, and usually that stuff can add up anywhere from, say, 15 to 25 extra VA, somewhere in that range. So we're going to save that. Yes?
Quick question for you about the capacitors again. About 5 years ago, the console units, 1201 and so on, they didn't come with the hard starts, and we were having a whole bunch of them going out and blowing up like that. And now we're seeing the new ones come with hard starts. What's the deal with that?
Here's the deal with that,
and the chassis for Concord, same thing.
Yeah, I wish I would have actually brought, okay, so about 5 to 6 years ago, enter onto the picture, okay, a whole new influx of hard start kits. And how it all started was, you guys may have seen some of these, they're called IntelliStarts, and they're a white box. And the white box, what it does is it's a timing mechanism. There's a little board in it. And what that'll do is time your compressor so that it releases voltage to it at a higher rate than what just a standard capacitor will do. So it'll bang that compressor on a lot faster, thus it has less starting torque, less starting amps. So within the last 5 years, okay, Puget, Seattle City Light, Puget Sound Energy, they've wanted to reduce starting amps of compressors. Because this has started not just in the state of Washington, but all over the country, okay, all these other littler companies like Copeland, okay, because a lot of them probably say Copeland on them, IntelliStart, various other smaller companies, develop these little boxes that are start assists for compressors. Some of the manufacturers, you're probably seeing it on Trane, Lennox, all the other different style machines out there, if they're not digital. And all of a sudden they're putting these things on as standard equipment. That's probably what you're seeing. Okay. So I think they work. I've watched videos. I've seen it with my own eyes. I think it's not bullshit. It actually is doing something. I put an amp meter on it, my archaic amp meter, and it works just fine, and it's less amps on a startup. So I think they're a good thing. Now, that being said, the problem is also solving itself. Okay, so now with dual stage heat pumps, okay, you don't need them anymore. I took out of my house a single stage 3-ton where I got brownouts. I put on the IntelliStart. Brownouts go away. Awesome. Maybe about 10 years ago I did it to an old recip. Took that out, put a brand new heat pump, decided not to put the IntelliStart back in. So I started up on single, it's a more efficient piece of equipment, yes, but it starts up on single stage, no brownouts. It's solving itself. So it was just a Band-Aid for that 5 years. So I think whenever we start seeing the advent of 2-stage or unloaders, you know, I think it'll end up going away. So that'll be out. So, but we'll see. So, but that's that deal. We're gonna save that. Oh yeah, let's do this one. Relays, okay. We stock a lot of relays. All of you guys have different uses for these relays out there in the field. We use these all the time, okay? This is nothing more, this is a 5-pronger, okay? That's what we call them. Lot of lockout relays out there for older machines, all the 804, 814s, H-series Climatemasters, okay? Those had what's called a lockout relay. This is what we have used over the years, you know, the $19 special, because lockout relays have failed a lot out there in the field. We have wiring diagrams developed so that you can take your 40-year-old piece of equipment, buy a $19 relay, and boom, this becomes now your lockout relay. So it's going to encompass your high pressure, your low pressure, which is about all there was back in the day. And it'll tie into this. We'll give you the diagram. You got to put a jumper here and a jumper there, and this will then become your lockout relay. Now, some of you other guys for different jobs like Watermark or we actually now have DC relays for you guys to operate boilerless systems. So this can energize, you can energize your heating coil because it's a DC type setup in the existing electric duct heaters, and it'll operate it right off the board. So we give you a harness, and then we give you a relay, and then you call Oleg and figure out how to tie it in. Or Offie, you know. So there's a lot of those. So there's a lot of these little fixes that you guys have been a part of.
Is that boilerless kit? I don't know what you call it.
The Oleg Special.
The Oleg Special?
Yeah, pretty much, you know.
Where is it? Is it a supplemental temperature sensor also? Is it using something in
No, it's just, so the temperature sensors are the DXM board.
Oh, okay.
They're already on the board.
On the one?
So, on both. They're on both, but they're on the DXM board, so you guys have, on boilerless, you'll adjust dip switches. Okay, and if you haven't done it, just call, okay, and we'll walk you through it, which dip switches and what temperatures you want. But we also see out there in the field, a lot of people, just yesterday, you know, I had a guy call, and I'm like, tell me where your dip switches are, and he goes, well, I got all these on and all these other ones off, and I go, why? He goes, well, I'm not using them. I'm like, yeah, but that's not how they came. He goes, well, I think I got a bad board. I think you should change the dip switches. He just wouldn't do it. I'm like, I'm not helping you until you change the dip switches. So I said, call me back after you do that. Well, it was 3 days ago.
So is that sensor actually on the coil, or is that off of like FP1?
Refrigeration line.
FP1.
Yeah.
Okay.
So let's talk about FP1 and FP2 real quick. Let's just touch on it real quick, okay? So FP1 and FP2, the design of them, okay, is they were refrigeration temperature sensors, but they're designed to assimilate the water temperatures. And they actually do a pretty good job over time. If you're looking at it after 2 minutes or 5 minutes, no, it does a horrible job. Okay? But if you let it run for 15 minutes, you'll notice that the LT1 temperature and the water discharge temperature are within a couple degrees. So If you allow it to work, it'll work. If you allow for, if you're looking for instantaneous information within the first 5 minutes of compressor operation, you will not get what you're looking for. So it does take time. So there's other scenarios on LT1 and LT2, like bad TXVs, that we started probably, maybe 4 or 5 years ago, kind of figuring out. And that's why we started taking those temperatures ourselves manually. And then enter onto the picture the DXM2. We don't have to do that anymore. So, but we do on a DXM board. So we'll actually many times take the temperature of LT1 and LT2 prior to calling someone in saying, hey, I think you need to gauge up. It's almost like us gauging up, putting that temperature. We go, oh, we got a restriction. Oh, no, I got low charge.
Those are different than FP1, FP2?
Same things. Yeah, so FP1 is LT1, FP2 is LT2. Exact same thing.
FP1 would be inlet into the expansion valve.
Yes.
In cooling?
In heating.
In heating.
Yeah, in heating.
So that's telling the water temperature of the coil.
Yep.
And then the air, FP2 is the air coil.
Is give us the air temperature.
Give us the air coil coming out of the expansion valve.
Yes. Yeah.
So if you're getting frost across your expansion valve.
Right.
Yeah.
Okay.
You can tell, and you run both modes, heating and cooling. You can tell based on the temperature of each sensor right away that it's a TXV or charge. You know, you usually can't just look at it in one mode. You have to run both.
By putting your, like that 80 PK, that temperature thermistor.
This guy here?
The PK 80, whatever that thing is.
Yeah, so units that don't have DXM2, we'll just put that right next to the sensor on either side of the TXV.
So let's go back a few years, okay, and talk about TXVs, okay? So, because it still haunts us, all of us out there in the field, and so let's discuss what happened, because you guys are going to see this for years still. It's still gonna happen on older pieces of equipment, but there's a couple things that happened because of it that enabled us as an industry, as service techs, to diagnose things a lot faster than we would have normally been, okay? So here's what happened. Copeland, okay, starts making scrolls for the industry. Enter onto the picture R410A, okay? Copeland makes these R410s, specialized in it, sells to all the major manufacturers. When I see major, I'm saying Train, Carrier, Lennox, and now let's talk about the smaller manufacturers like the Climatemaster Florida heat pumps, water furnaces, okay? They all bought the same compressors, okay? All scroll. Copeland advised all these manufacturers to utilize a certain cleaning agent for all of their copper piping at their manufacturing facility, okay? Because they're good bunnies and they wanted to keep their warranties in place. What do? They do exactly what Copeland recommends. So these guys are all of a sudden buying piles of this cleaning agent, okay, to clean their copper, to then hook up the fancy Copeland compressor so that life will be good. Enter onto the picture, okay, Oleg. Oleg gets a phone call and he says, Mike, there's something wrong with this heat pump. I think it's a TXV. And I'm like, TXV? We've never had TXV issues before. Oleg, what are you talking about? Well, sure enough, bad TXV. He puts in a second one, bad TXV. Okay, this is now 2, okay, and we're just small players. We try and start getting to the bottom because now we're getting more phone calls. We're getting more, okay? This is becoming a bigger issue. It's like, holy cow. It's probably, like I say, 4 or 5 years ago, somewhere in that range. So we start going like this to Climatemaster. Climatemaster hears us, okay, and they start going like this to Sporlan. Sporlan gets blamed, okay? Sporlan says, I want all the TXVs back. We send them all back, okay? And this is just us, little old AirTech in Washington. Send them all back to Sporlan, okay, across the nation. They get them all back. Problems all over the place. With everyone's piece of equipment, it's like a disaster across the country. Residential users, everyone, okay? Sporlan gets back to the manufacturers and they say, wait a sec, this isn't TXV issue. All my strainers are plugged. What are you doing? What's all this crap that's on my TXV? This is not ours. Where'd this come from? Warranty denied. Warranty gets denied. Climatemaster kind of jumps on it a little quicker, say, than your Linuxes and your Trains. They go back to the old agent without telling anyone because they didn't have this problem with the old agent. Their problem stops much faster than the rest of the gang. But they don't tell anyone because they don't want their warranty of the compressor affected. Takes Copeland, I'm going to say, a year to own up to what happened. So what happened was Copeland says, hey, I don't want to lose, I want to sell the cleaning agents too, along with my compressor. Here's the new cleaning policy that you need to provide at your manufacturing facilities. Everyone does it, okay? They start to do it. All of them start having the same problem because these cleaning agents were millions of dollars, millions of dollars. All of a sudden Copeland backpedals. I confronted Copeland at the ASHRAE show because now I'm pissed. And Climatemaster is very careful about, and all the other manufacturers careful because Copeland's big boy. They're the biggest boy. So you don't want to have them cut you off or anything like that. But I'm like, to me, I'm like, screw it. I don't care. I'm going right into their face right now. I want them to know what they did to all those service contractors and all those end users out there. They would not talk to me. They would not talk to me about the matter. So the problem went away fairly quickly, okay? But out there, what it enabled us as a service group to do is learn about TXVs really quickly. So we learned about TXVs fast to where we were able to diagnose them extremely fast because we're out going to look at it. So they're wanting us to, they're going to sell us a new TXV, but first they want us to put this agent in, and we called it the magic soccer juice. You guys are probably, some of you have heard this before. So they'd give us the juice, they'd give us a new filter dryer, and they'd say, here's your installation method, here's how you put it in. You put it in this way, and then you cycle back and forth between heating and cooling. And a lot of times, it would break it up. And they were right, and it worked, everything worked fine. A lot of times it didn't, okay? We said forget it, and we just kept changing the TXVs.
It really only worked on if you caught it within the first 2 months.
Yeah.
Anything after that, just replace TXV.
And it didn't happen on maybe 20%, okay, of the machines, but to us that was too much. So once we learned about it, figured it out, okay, now it's gone. It's a non-issue. But again, because of that, I think Climatemaster went to the LT1, LT2, enabled us to get a little bit more information on how to diagnose them faster. So we know what those numbers now mean. We didn't really know what they meant, say 10, 12 years ago. Now we do. So now we can diagnose it very quickly. Low charge, bad TXV. So it did help us from that standpoint, but that's what the bottom line was. It was Copeland, the whole thing. So
we had to find out by finding a YouTube video.
Yeah, we found a YouTube video online.
I found a YouTube video that some guy talked about what happened.
I use startups for another selling agent.
Right.
I did startups for Daikin and Data Air and a bunch of other stuff. And I kept doing TXVs, and so I started taking them apart, and I had some good pictures. I can't seem to find them, but it looked like somebody had left it in salt water for an extended period of time on the spring, and there's a plate, and the needle, everything was covered in this stuff. But on one side it was, on one side it wasn't. It was really weird, and it was thick. It was really thick.
Yes, depending on the flow of the refrigerant.
Correct. And yeah, that's how I found out. I started doing some research, kinda like you guys did, and I was like, what in the world? But it, it started and then it ended real fast.
Yeah, it went away really quick, so it's gone now, okay? But, I mean, it's still out there. It's good for you guys to know that, because McDonald Miller was probably the quickest to let us know, as you can imagine, okay? So we started getting a call from the hierarchy at McDonald Miller, and yeah, we take that fairly seriously. So we immediately start looking into it ourselves. So
We actually installed it ourselves.
yeah, so we went out and put the magic soccer juice, you know, and you watch soccer games and stuff, and all of a sudden they go out there, and oh God, the guy's fine all of a sudden, you know. So
Yeah, we took it to a residence and we gotta make sure it works.
yeah, so anyway.
Somebody's house that you're not
Yeah.
Not your house.
So that was that's the TXV issue.
So was this the cleaning agent they used on the copper before they did?
On the copper, in the copper piping.
Rust inhibitor, wasn't it?
Yeah, it was a rust inhibitor, and if you didn't use it, you'd lose your warranty. That was the ploy.
They would have to prove that she didn't use it, right?
They would have to prove, so you.
Every unit that's working.
Yeah, so they'd have to prove, but can you imagine how long it, and then plus,
Yeah.
then they'd like give you a few bucks, and when I say a few bucks, like, okay, let's go to McDonald's and have lunch, you know?
And they did that for 5 years?
They did it for 3, maybe 4, but Climatemaster only allowed it to go on for 2. Lennox got it the worst. Okay. Lennox got it the worst, and then they lied, and so did Carrier. Lennox and Carrier lied about the TXV to service contractors and wouldn't give them anything. So, but, you know, I mean, with your guys' help, we whack a fairly large stick, so we were able to get fairly serious with them fairly quick.
Yeah, we thought it was gonna be a lot worse, but we got right on it.
Yeah, so it slowed down for us, so, and boom, kind of non-existent, but again, the useful thing was we learned a lot about TXVs fairly quickly, fairly rapidly. So, anyway, that's TXV. So, let's cover hose kits. Let's just touch on it. Auto flow versus Venturi balancing. You guys obviously walk up to lots of hose kits really fast, and you're going, well, okay, let's just open her. Okay, that's pretty much what I do too. So this is an auto flow kit. It's pretty much for balancers, but it's not bad for you guys to at least know. Okay. On auto flow, it's fairly simple. Okay, you got 2 types of balancing. Okay, you got your auto flow valve and you've got your Kit B or Venturi balancing valve. There's pluses and minuses to both. Okay, I'm going to pass this one around. On auto flow, okay, as far as the balancing valve goes, it's set for a specific GPM. It's set for a certain pressure differential range, normally 2 to 32. Okay, so let's just say it's a 1-ton machine and we set it up for 3 gallons a minute. Okay, for between 2 and 32 PSI. Okay, pretty easy. Hey, I buy one of those, I put it on my 2-ton heat pump, off I go. Okay, life is good. And I do that for the whole building.
So
Okay,
as long as you have between 2 and 32 PSI pressure differential between
at
the
that
side-
cartridge.
At the cartridge, it's going to spit you out 3 GPM exactly. And those cartridges go down to 1/10 of a GPM, so you can get them for 2.1, 2.2, 2.3, 2.4, all the way up.
Now, okay, here's the fine print. Okay, fine print is, that's within 10%, okay, per the factory. And it's magic. Okay, so the spring range, there's nothing verifiable, okay, other than you're between 2 and 32 PSI.
and it's supposed to be giving you what is cataloged, okay? But that's still, okay, not the answer. It's not a perfect world, but it's easy because you don't have to balance it, and it should be giving me this, okay? So that's that. Okay, then there is Venturi balancing, okay? This is Venturi. There's a Venturi in this valve, okay? You can go to a chart, okay, just like airflow, and whatever this, the reading is between these two, you can go right to a chart and say, okay, boom, I'm getting 2.6 GPM. You can adjust it a little, it'll change, and all of a sudden, okay, I'm now getting 1.7. It's verifiable, okay? Obviously, I like it because it's instantaneous. Okay, you can get it right away, you can adjust it. Now, there's minuses, it doesn't adapt. It does not adapt to a change in pressure in the system. Okay, McDonnell Miller uses a lot of these. Okay, the industry has semi-adopted them because of McDonnell Miller. And again, you can get an exact answer. Lots of advantages to Venturi balancing.
That would be considered a pressure dependent.
That's a whole different valve. Pressure independent is a different valve. So I'm going to show that one next. I brought that up too. So,
So, quick question.
yeah, go ahead.
The two measurements that you're talking about on the Venturi, and you go to the chart, how are you getting those measurements?
You got to plug in a tool of which we brought and I left it in the truck.
Pete's plug?
Yeah, well, through the Pete's plugs, and it'll give you a differential reading.
Can you grab it?
Yeah,
Could you
yeah.
use a Pete's, like if you had a Pete's plug that read like 0 to 40? Well, because you're
No,
looking at
you
differential,
can't.
so it depends on your water pressure.
Yeah, no, so, yeah, keys. So we'll get the tool. All your balancing guys have them.
But your
And
temp,
it-
your temp, water temp will tell you the same thing.
That, now we're gonna get to the old school stuff,
Your
okay?
water in and out will tell you.
So,
That's right.
that's Venturi, then you got AutoFlow floating around, okay? Those are the two, I want you just to kind of be familiar with the two styles. There's lots of reasons to go to both. I like Venturi, strictly because you don't have to at least add 2 PSI pressure drop to your system pumps, okay, to make sure that my spring will work. Okay, 2 times 2.31 is approximately 5 feet ahead. That means I need 5 feet ahead extra, okay, on my pump or more to account for all of these valves throughout the system. So, and most of our pumps are now set up on VFDs.
Where's your cartridge?
Which one is that one?
There's supposed to be a cartridge.
No, that's the blow down.
Yeah, but isn't this the auto flow that sets, isn't there supposed to be?
No, that's the other side.
Oh, that's the
That's the strainer.
Yeah, but a lot of these have they'll have that little cartridge in there with the spring and the little depressor.
Yeah, no, that's just the strainer side. It's still floating around someplace, the other one.
Oh, is that other one?
Yeah, there it is. It'll come
Oh,
over to
this
you
is
next.
just this is just a.
That's just the water inlet. That's the water inlet. So, anyway, so I like Venturi. I mean, that's, my personal opinion. Okay, now, you're gonna start seeing out there what's called pressure independent.
You might want to touch on, just so if everybody knows, the proper way to blow these strainers out.
Okay, the proper way to blow the strainer is, number one, get it out.
Yeah, number one, get it out.
So once you get the strainer out, okay, it's like a little mesh, call it probably 60 mesh or a 40 mesh, something like that. There it is right there, okay? You take it to a sink and you clean it, and then you.
And if you can't get it out, someone's rounded it off.
And someone's gonna go in with a couple, 2 flatheads, and then yank it out as best you can.
One thing you want to avoid, for most people know this, but if this is say this is the inlet, so if this would be our flow, something like that.
Yeah, that's right, yep.
A lot of guys will just open this up and blow it and say, oh, it's clean. What you need to do is shut this valve off here,
Flow the other way.
flow it the other way so the water comes backwards through it. Cause otherwise, all you're doing is if you take this apart and look at it, you're just blowing down the center of the screen. You're not cleaning out the mesh. But if you close off this valve and have the water go backwards, now it pushes the gunk back from the outside to the inside of the screen and blows the screen out that way. Makes a big difference. Now, it's no substitute, like Mike said, for pulling it out, but that being said, there's cases where you can't
Can't get it out.
you can't get it out, you can't open this thing up, it's messed up, whatever. At least blowing it out the proper direction gives you a chance.
Get a fighting chance on it,
Yeah,
yes.
versus doing it the wrong way. Which
Okay.
does nothing.
You guys
Hardly anything.
probably haven't seen a lot of these, okay? This is a pressure independent. You're gonna start seeing more. You're not gonna see them on water source heat pumps, okay? I just thought because I had it, and we've been playing around with them, I thought I'd bring it anyway just to show you. This is gonna be more on fan coils, okay? Fan coils, chilled water systems, it's code on 10 gallons a minute and more to have pressure independent, okay? Pressure independent is a settable GPM, okay, controlled by a modulating valve. With a 0 to 10 or a 0 to 5 volt DC signal that comes from something, okay? What, it doesn't matter at this point right now for this conversation, but they're out there, okay? The great thing about these, okay, on a pressure independent, it's gonna adjust to the system pressure, assuming the system pressure is anywhere between 2 and 80. So they're pretty forgiving valves, okay? It may be a good thing for the industry, it may not. I don't know yet. The jury's out. So, but this is what it looks like.
And that little controller just lets you adjust the GPM
Do you have a
that that valve is set
This
for.
thing up,
So you can
Mike?
plug it into the valve.
Do you have a wrench to open this thing up? Jesus. Never mind. Somebody had a cute little pair of Nipix channel locks.
Okay, you guys have probably seen these things, okay? These are the old school motorized water valves. Many of you have seen these, okay? This was the first rendition to motorized water valves that kind of came out, the old Eries, okay? You've seen them out there. These pins always broke off. Finally, within a year or so, they went to the real deals. Finally, Climatemaster settled on the tacos, which we like a lot. We have very low failure rate on the actual actuator head. You can take off the switches right there, okay? They have an end switch. It's pretty good. You don't have to use the end switch, but they have it, okay? And it seats pretty decent. And it's easy to get on, easy to get off. So here's the old school, here's the new school.
They're really easy to hook up to.
Yeah, they're cake.
Unless you don't know. And then they don't make any sense.
Okay. There you go. You cover the parade. Let's go ahead and discuss the noisiness and how we've found to solve it.
So this is the two-way motorized water valve that we sell, and most of you have probably seen these and hooked them up. I know you have. Power open, power closed. The reason we went to the power open, power closed is mainly because of you guys, because you needed something that was quiet. However, you're finding they're not so quiet sometimes. I don't know, has anybody here ran into the noisy ones? So we finally figured it out. And it is, you have a small.
I do, yeah. It's right over, all my tools are over there.
I don't know the small.
Valve set though.
Yeah, it's the gears, and so we finally figured out how to fix it, and we've made Bray aware, and we're hoping they're gonna do something about it, but, anyway. So, how many of you have actually ran into the noisy ones besides you? Okay, so you did. So, in here is this is where the gear is. And you'll notice as you're running these, I don't have a setup for, well, anyway. You'll notice as you're running these, this is where the sound's coming from. You can kind of press, this will be turning, you can kind of press on it and get quiet it or make it louder. But essentially, all the problem is this screw right here. And it's because it's making it rattle somehow. So I went and bought these tiny little O-rings and put it under that screw, and you can see I got one. You just pass that around. So that is the fix for now.
It removes all noise.
Yeah,
Huh.
always.
I was just thought it kept trying to,
That's what we thought too.
Yeah.
That's what we've been chasing on too, for like a year.
Because that's what it just sounds like.
Huh?
It's not noisy, I mean, it's not that bad. Like a, you know what I'm saying? It's the cog. We were chasing a different thing. We were chasing something else that wasn't even that. And
Never think.
Yeah, I mean, it's fine.
no, because it's only matters when it's an open ceiling, you know, how often are those? But it pissed us off, so we finally went after it, so.
I took it in the screw and I was like, I need some little.
Is there a part number on that?
Yeah, H70004. And they're like,
Is that something, like, how many people have heard that noise? Is that any source of complaints above ceilings? Is it?
Not above ceiling, it's when it's below the ceiling.
So you don't hear if it's above a ceiling?
Not really.
Is it when it's just sitting there stationary, or is it just when it's stroking? Oh, it's stationary,
Yeah.
it still makes a noise.
It makes it sound like it's trying to keep
it
closing.
varies though, because some of them, it's loud when it's stroking, and then it's quiet when it's fully. Some of them it's quiet when it's stroking, and it's loud when it's fully stroked.
When I,
And some only do it one way.
And that's on the brake valves?
Yeah,
I've only heard it when it's closed, and it's
yeah, it doesn't,
closed, and it sounds, like I said.
Yes.
It sounds like it keeps trying to keep it closed, and that's the only time I've.
that's all, it doesn't cause the valve to fail or anything like
No,
that, it's just, and it's just, so it became annoying and we just decided to solve it. We wanna get to it.
It's so it's so all over the place, there's not.
It's just, and sometimes it doesn't, sometimes.
And that's another thing, sometimes the valve's noisy, sometimes it's
Yeah.
not.
We probably sell 1,000 of these a year, 1,000 of them. And we get maybe 10 or 20 complaints out of them. And it was just like, okay, well that, you know, one day, it's one Friday or something, we got one too many that day.
Yeah.
And that was it, today's the day. So that's how it came about.
And we had a freak out and sent, like I said, like 75 back, and then the noise persisted, and so we figured it out. And like I said, it's only.
So you've been
it's
able to,
only in the
you
downtown.
took that screw off and then put that O-ring on, and then it.
We were literally able to just loosen the screw. That solved it too.
Yeah, you back it off, but you don't want to.
Just back it off just a little.
So.
So it was like over tightened, just a pinch, and then that solved it as well. So we just wanted to go to the next step, and we found, that's what we found that.
But our hope is that Bray solves it and does their own O-ring, so that we don't have to be doing in the field or doing on every one we get. So that's why I actually bought a shitload of O-ring deals.
Have you been putting them on at the shop or no?
Hey, don't break our stuff.
Bray's coming. I think it's-
No, it doesn't, it's not for that one.
Like I said,
I'll tell you why it's not working.
It's nice.
we ship like 5 a day.
I think Dexter Horton, there was quite a few, but I think that building is jinxed, and so that's why all the heat pumps didn't wanna work. And so I just said that the rain valves didn't wanna work either, but.
I would say like 5% of them, maybe.
We don't know how many are.
Yeah, we don't even
It's
know.
really hit or miss.
It was a Friday, and we'd have it, you know, so that was it. So, CMC boards. Okay, so, you guys have probably seen some of these out here, some of the older techs, okay? Maybe some of the newer techs, okay? This was the original, Climatemaster version of getting into the solid state industry. This started in 1996, okay? So in 1996,
the industry starts to change and try and go to solid states to a limit, to kind of get out of analog, okay, and get into digital, okay? This was their version. First couple years they worked fine, good, you know, they had pretty good luck with them, okay? Okay, then they went to an alternate manufacturer, probably to save money, who knows, in Israel, and poof, all of a sudden, we're having problems with the boards, okay? So they kept advising us that it was a ground noise issue, okay, ground noise issue. That was not the case, okay? It was something internal to the board itself, okay? They solved that, but they ended up going to the DXM board, redesigned a new board, go to the DXM, which is where we're still at today with the DXM boards, which is it started in 2001, so obviously the DXM board itself has been a pretty good solution to the CMC, and they've stuck with it, okay? Now, however, there's some anomalies about these things, as Oleg wanted to remind me while Kenny was going through the boards, is this particular board, back in the day, they utilized it as half-wave rectified, okay? What that really meant is between R and C, okay, you would measure 13 volts, approximately.
DC.
13 volts. AC, 13 volts AC. Still, not enough to run a programmable thermostat, not enough to run an Allerton Tux, okay? Not enough really to do anything. Nothing would work, okay? Including their own reversing valve, which was 24 volts AC. Okay, so you'd have some issues with reversing valve solenoid coils. So,
Chainsaw.
or, yeah, or this was also set up for a heat-cool thermostat. You probably are out there with these and you've seen them on heat-cool thermostats and you're going, why are they on a heat-cool thermostat? Why is it not a heat pump thermostat? Well, because Climatemaster, in their infinite wisdom, thought, hey, let's go to half-wave rectified so we can control 3 units at one time off of one board. We don't know why they made this decision on being able to do this, but it made no sense to us. So we developed fixes so that you could run a heat pump thermostat. You probably have seen some out there wired. We developed wiring diagrams so that you go to a programmable heat pump thermostat so you wouldn't have to change the stat out if you put a new heat pump in. And then you would run from the stat, okay, directly to the reversing valve solenoid coil. So you go from P, one of the P's right over here, okay, to the reversing valve solenoid coil, okay, or you'd run the P up here to R, and then at O, you'd go over to the reversing valve solenoid coil, and then run C to the other side of the reversing valve solenoid coil. So those are the fixes we came up over the years, okay? There may not be many of these out here because there's a CMC conversion kit. So a lot of these may be gone, but there's still a lot out there. So if you come across this and it's working fine, you'll see that we'll ask, and maybe some of you know, we'll ask you, hey, does it have a galvanized shelf on it? This is what we're talking about, this galvanized shelf right here. So, because a lot of the times you'll go, well, it has the 4 lights on it. Okay, well, that's one indicator. But we're looking for, okay, does it have the galvanized shelf? And if we all of a sudden know that it's the galvanized shelf, we're like, oh, okay, how's it running? We're gonna ask you questions about how's the board running? Is it doing what it should be doing? But if we find any anomaly, we will advise change it out with a DXM conversion kit, which is really easy. It takes about an hour, basically, basket to casket, and poof, you'll have a whole new brain for the existing heat pump that you have installed in there. Again, some of you guys have probably run across this. I know you have. So,
but that's what this is. But there were many, many units out there that had this.
You said that one's from 96 to 2001?
It was about 95 to 2000, somewhere right around in there. So.
Is that the one that has the four little lights they have little wires sticking up?
Yep.
They'd give you a problem with, they'd say like low pressure or high pressure or condensate overflow.
Oh, yeah.
And then,
I had those trip out on both, low
Yeah.
and high at the same time.
I believe you. I've had all types of things wrong with those things. So, and then, the funny thing is you look in the manual, okay, and it's like, the manual's like, okay, well, if it gives you a color coordinated blink between, condensate to high pressure, then it's this. I'm like, oh, God, are you kidding me, you guys? So, that's kind of how we cut our teeth on boards, okay? And we had to learn a lot. Eric and I had to break into schools, okay, to fix those things. So, only to find out it wasn't even the boards, it was Griswold, so, but you know, whatever. But anyway, that's the board. Just want to make you familiar with what's out there so you know, so it's not a shock. Next, okay, I want to spend a little time on Ecm Motors. Okay. We've had to learn a lot about Ecm Motors. There's more and more out there. You guys are getting involved with more high-end condos, okay? ECMs are great, okay, provided they're not misapplied. I know that's not your guys' department, okay, on, you know, application or non-application, but I want you to be familiar with how they operate. So, with Climatemaster, we do it two different ways, okay? One, the traditional way is you'll have an ECM board, okay? That's the majority of the ones you'll see, okay? So they'll have an ECM board where you hook up your thermostat, and then the wires will go from that board over to the DXM board. And then boom, that will control heating, cooling, whatever stage it's in, that kind of stuff. So, and they're pretty quiet. So it'll have a soft start. It'll have fan only CFM. It'll have heating stage 1, heating stage 2, cooling stage 1, cooling stage 2, and dehumidification depending on what you're after. But approximately 16 different speeds, and then you make adjustments. That's how that board works. Or there's the DXM2 way, which is, Kenny already showed you, so I'm not gonna kind of touch on that. Obviously way better, this version, because you can adjust within 25 CFM increments, okay? That's a hell of a lot cooler. These, work in progress for us, guys. Okay, it's a work in progress because we're not satisfied with the troubleshooting ability out there in the marketplace to troubleshoot the motor. So we're still working on it, so all I can tell you right now is we're working on it. We want more information. We want more information, not from you guys, from the manufacturers. And this is across the board. You guys are running into it with Greenheck, okay? All the different manufacturers, code, ECM this, ECM that. Motor ain't cheap, $500 to $700 per motor, okay? Versus a PSC motor that's 150 bucks. So, yes, they don't fail very often, okay? I'll grant them that, okay? They react a hell of a lot nicer on situations of high static pressure. Awesome, okay? But still, I don't think the troubleshooting techniques are up to snuff on that yet.
I don't know anybody that knows how to troubleshoot these.
are most of yours the remote module or are they integral module? Like, I like that one up there, that's a remote module.
We have two different ones. One's an integral, one's a remote.
This one is
That one's the integral, this one over here.
it's still a separate piece, it's just attached to the back of the.
All they do is attach it to the bell.
So, the farthest we've gotten with actually being able to troubleshoot them is Climatemaster has a ECM diagnostic tool. And so you basically plug that into 24 volts and then plug it into the low voltage. And then all it tells you is if the control module is bad or if you need to check the motor. So it doesn't really do much, you know. Yeah, it's fine if the module's bad, but if the motor's bad, you know, that's what we're still working on, trying to figure out how to troubleshoot.
So I got no information for you on that, other than you may run across it in the field. And hopefully by that time, we'll have more information for you guys to troubleshoot that yourselves.
And we will have a tool that we can borrow out to you guys.
So,
Have you tried any of the, there's some tools out there, I don't know if anybody in here has them, that you can plug into those modules, and then they have little switches on them, so like you can simulate different speeds. I know Travis had one on the east side. You guys have any in this room?
I have one, but just a single switch on and off.
It's a single switch one,
Yeah.
for like an X13 or something.
is that the NIDEC one?
It might be a NIDEC.
Model
Yeah.
number, but
There's a few of them
yeah,
out
it comes
there.
with a plug, so you can plug into different ones.
This is it right here.
I'll put it on my
This is all you need.
tool request.
Center. Center
It works.
Service University.
Yeah, so that's, we're still playing with it. We've had a couple of different tools, still, we're not really satisfied ourselves with it. So, other than change the motor out, and by the time you do that, it's, yeah, again, we lose very few of them. We don't even stock them, because we just don't lose them.
Yeah, you just walk through this whole.
It's usually the control module. It's all.
Yeah,
Well, it's just a three-phase motor, right? So you can still just ohm through
single
the
phase,
windings.
single phase.
But the ECM motor is still a three-phase motor essentially, so you said,
No, well, yeah, the ECM motor is single phase. Single phase.
But the motor ohms out like a
Oh,
three-phase.
does it? Okay, I didn't know
so
that.
it's still three run windings in there, so you can still ohm through the motor like a regular three-phase motor.
Yeah, we have actually yet to find it be the motor, it's always been the
Yeah, right, so if you.
Everyone I've changed the motor, the motor's always been okay, it's always.
Yeah,
It's
so
always a headache.
that's how I've always done it. It's acting weird, pops the head off, ohm through the motor, and then ohms out okay, and you're getting a signal for it to run. It's a head.
Yeah.
But
The nice thing about these ones is you can go, you know, you open your fan panel and it's just 3 screws to take the module off. So if I find one bad, I usually just do the module first, and that's what it's always been.
yeah.
It's
That way,
never actually.
that's what, everything else stays installed.
Right.
Well, and then our ECM motor class, he said if it's bad, replace them both. He didn't even give us an option.
Yeah, he said you don't have to buy replace
They
them,
took
just
a
buy
class, he's got a PowerPoint on it, he's gonna send it.
Yeah, dude, oh, good, yeah, but we get a little bit more, yeah, well, yeah, it's like, okay, what's bad, this or that?
Pretty much he was talking about doing the flick test on the, was it the MPT? Is that what it was? Right? Yeah, so the one little resistor that's on the top of that module.
Yeah,
Yeah,
We noticed that one's kinda loose.
Basically, what he always did was he always said that he went up and flipped it, and if it came off, replace it all.
What do you?
He was also like an Italian officer, so.
You don't have it.
Yeah, no, there is a black one.
What's in there?
Yeah?
wow.
Yeah, that one's kinda loose. If you wiggle it.
No, there you go. It's usually right dead center.
You notice
So
how
that,
loose
that's
it is?
also, we're saying that
That was it, I'm done.
every guy
Yeah.
you buy them, you're basically.
Yeah, this is a bad one. Probably why. So you said that.
Anyway, guys, that's it. That's all we had. You know, we got cards. If you guys want to call us, I'm sure you all have our numbers anyway. But that was our. Seth asked us to kind of put on more of a, you know, more of a workman's type shop, and so.
Throw that to that clock.
I didn't know if you had.
From the manufacturer's point of view, like,
So he
Just
said,
don't
separate
everything.
Yeah, I mean, that would be great, we don't know.
but if you have some dippers over there.
But yeah, you just go through everything again, like, US motors.
Oh, yeah, yeah.
Like, who makes that motor?
Huh? Sure, I'll find out.
We had.
You know the engineers, they know the stories.
This is
Do you have any?
I spent a lot of time here. This is
Hands
dealing with the air.
What?
He always gets